but hard water often produces a deposit to containers, including bathroom ring. It is not caused by a single substance, but a variety of dissolved polyvalent metallic ions, mostly calcium and magnesium ions. Hard water requiring considerably more soap to produce leather, but instead it produces scum instead of leather. Hardness of water is generally of two types: the temporary type of hardness and the permanent. The temporary usually is caused due to bicarbonate of calcium as well as that of magnesium, while permanent hardness usually caused by the presence of calcium sulfate and magnesium sulfate, and it cannot be reduced or minimized simply by heating, but mostly using ion exchange chromatography. The methodology of the research. Sampling site. Turkish Republic of Northern Cyprus is divided into 28 municipalities, by which tap water is provided to the public. Water samples were collected from 6 sites within the period of 24 to 28 June 2019. The samples were stored at 12 degrees Celsius until or prior to analysis. The samples were collected in 0.5 liters polyethylene bottles, just like these ones. But they are washed several times using deionized water. This is a map of North Cyprus. Municipalities, yes. The materials used during this experiment. We use a bopper containing ammonia, which was purchased from Riedel, as well as ethylene diamine tetraacetic acid, EDTA, from Sigma Aldrich. Standard calcium nitrate tetrahydrate, also from Sigma Aldrich, and Eriochrome black tea indicator, which was bought from Pluka. We are used throughout this experiment. The procedure. Ethylene diamine tetraacetic acid solution was standardized using calcium solution with non-calcium concentration, that is 10 millimolar. An aliquot of 50 ml of the tap water sample was transferred into 30 ml of Erlenmeyer plugs, then 2.0 milliliters of pH 10 buffer solution was added in order to mask the presence of the calcium and magnesium that are present in the water sample to form complex with the calcium ions, which changes color from blue to pink red. Titration was then performed with 0.01 molar of EDTA solution until the endpoint was achieved. At that point, calcium ions were complexed with EDTA solution and a sudden color change occurred from red-pink to blue. Each sample was titrated 3 times and the average of the coordinate result was used for the calculation. And this shows the equation of the reaction, in which calcium ERIO2 complex was initially formed after adding ERIO2, which is a very weak complex because ERIO2 is not as strong as EDTA. Then a displacement reaction will take place by EDTA, which will displace the ERIO2 and it will free the ERIO2. Then we will observe a color change. What is the essence of doing this? Initially we can treat calcium together with EDTA, but we couldn't observe any color. Because EDTA is colorless, calcium nitrate is colorless, so we need to bypass it. Simply by using the ERIO2, it will change a color, then after adding EDTA, it will displace and show another color. And this is what I just explained. The results. The total hardness in water can be expressed using different parameters, in which we use the mg per liter, that is in part per million, using the calcium carbonate scale, which can be calculated as follows using this formula, which is equal to the molarity of EDTA multiplied by volume of EDTA in milliliters, divided by volume of water sample in milliliters multiplied by 100,000. And this is the result. Based on this table, you can grade the quality of the water, in which if it ranges from 0 to 30, the water will be considered as soft, while if it is from 30 to 60 ppm, it will be considered as moderately soft. As well, if it is 120 to 180, it is considered as hard, and anything above 180 will be considered as very hard. And this is the result of our experiment. Leukosia, it has a concentration of 210, which is considered to be very hard, while Guzelyurt has a concentration of 162, and it's considered to be hard, while Magusa has the highest hardness of water, having 306. Lapta being the first, Lapta is the highest, having 446 part per million, which is very hard, and Girne 375, also considered as very high. Lepke also 398, which is also considered as a very hard, or in fact even very hard, since the scale is from 180 and above. Conclusion. In conclusion, the hardness of all the water samples were very hard, except for Guzelyurt, which was found to be hard. So future work needs to be done in order to revalidate and check, in order to find the reproducibility of this result of ours on systematic study of water quality, covering more regions and more samples, considering seasonal variations, maybe during the summer and then during winter, in order to check for the variations. In underground water, and comparison of the water quality status before and after the supplementary water provided by Turkey, that is from Mersin, which has been completely distributed. And this is the reference of my presentation, and thank you for listening.
So thank you very much. Please, do you have any question? So I will ask you about the water criteria. How you are doing this kind of test, and do you think that the criteria can be put maybe into a automated, maybe learning system to control it every day? And what do you think about that?
Actually, it's a very simple titration in which we use simple and inexpensive solvents and other reagents, because the name of this conference is on sustainability, which has to do with inexpensiveness as well as has to be green. The process is completely green, meaning that there is no toxicity or something of that nature. But they are inexpensive, as I said, but we have other techniques which can be better, like PAS, we call it flame atomic absorption spectrometry. It can be achievable and will have higher sensitivity and selectivity than this. Or maybe using graphite atomic absorption, or I don't know, if we have money, we can buy ICP-MS. It will be the best to predict this, and within a short period of time.
Thank you very much.
Thank you.